Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering the Module 5 Inquiry Question 2 question, which is going to be on Le Chatelier's principle. Here you can see this is from the additional chemistry sample paper. Module 5 question 12 worth 5 marks in total. We have an industrial plant makes ammonia from nitrogen gas and hydrogen gas. The reaction is exothermic. The graph shows the adjustments made to increase the yield of ammonia. So to increase the yield of ammonia, you can see there's a sudden spike in nitrogen. There hasn't been any change in the concentration of hydrogen though, so we can assume that there must be an increase in the concentration of nitrogen, and that's the only thing we actually did. So account for the changes in conditions that have shaped the graph during the time the system was observed, including a relevant chemical equation in your answer. Alright, so we want to write the correct chemical equation. Let's do that first, okay? If you write a relevant chemical equation, the relevant one we're talking about here is the formation of ammonia using nitrogen and hydrogen gas. We know that it will be 2 here, 3 here, and that is completely fine. So that's our relevant equation, and we know that in terms of the change in enthalpy, it is negative to represent an exothermic reaction. Okay, so let's look at time t, account for the changes. So when we say account for the changes, we need to also talk about why those changes were implemented. I might just increase the size here just so you can see the graph times as we go. So what's happening in T1? There is an increase in concentration of N2. Okay, so what's the overall consequence? Okay, so always refer back to Le Chatelier's principle. So according to Le Chatelier, I'll call it the LC principle. And this should be an equilibrium equation. My apologies. The equilibrium will shift towards the right, or shifts towards the forward reaction, increasing the concentration of ammonia to oppose the change, or to oppose the increase in nitrogen gas. Or the increased concentration of N2. Okay. And then we'll change color for the next one we're going to use. So this one is T2. So what we can see here is, we can see there's a spike in all of these concentrations. So if there's a sudden spike in concentration, there must be a reduction in the overall volume. Okay, so we either reduce the volume or we increase the gas pressure. So there's that. So T2, we've either increased the gas pressure or decreased the volume of the reaction vessel. Okay, the reason being because all substances concentration has increased. Okay. Now, according to Le Chatelier's principle, we can see there is an increase in the overall concentration of hydrogen, there is an overall increase in the concentration of the ammonia. Okay, the reason being is as we increase the pressure, we've reduced the volume, and so the site with the more moles in the reaction vessel, that being the nitrogen and the hydrogen, they're going to collide more regularly to form ammonia gas, whilst ammonia has less moles, so they're less likely to collide as much as the ones on this side. So all substances has increased. This ensures the reaction vessel, or the reaction with more moles of molecules, will collide, causing our equilibrium to shift forward again, and thus increasing the concentration of ammonia again. Okay. Last one, T3, and we'll look at using the color, another color. So we see that there is a rise in the concentration of nitrogen and hydrogen, and there's a slight decrease in the overall amount of ammonia there. So the last thing that could potentially occur is a change in temperature, and we're going to say that it is going to be an increase in temperature. Okay, so you can see this is an exothermic reaction. If I just write heat over here, this forward reaction is exothermic. Okay, by including heat into the reaction, that favors the endothermic reaction, which is nitrogen with heat decomposing back into nitrogen and hydrogen. So that's what we have here. It's a reversal going back the other way. So T3, we have an increase in temperature, which favors an endothermic reaction, or favors the endothermic reaction. Causing a reduction in the concentration of ammonia, but an increase in concentration of the nitrogen and hydrogen gas. And that's how you answer this question. So hopefully this has been nicely shown of how you can analyze graphical data and using Le Chatelier's principle and a relevant equation to explain how concentrations will shift in equilibriums. Thanks for watching, give it a like, and I'll see you next time.